Good evening and welcome to our Be a Star in ESA's Universe session on life support systems. I'm Tatiana Benavides, working at the Swiss Space Center as the Hub Manager and ETH Zurich, and also the Luna Project Manager. And it is my pleasure today to host this fantastic event. Be a Star in ESA's Universe started as an annual meeting in 2016. It is coordinated by the Swiss Space Center in collaboration with ESA and with the support of the Swiss Space Office. This platform is a unique opportunity for professionals, experts, and students to exchange and network. And this year, due to the circumstances, we're holding the event online in this new format. We have, instead of a roadshow where we go and visit different Swiss universities and do panel discussions, we're hosting this time 5 online events tackling different fields of study, which play a key role in the current space ecosystem. These sessions are being held this week and next week online through our YouTube channel, like you're watching now, and they are from 5 p.m. to 6:30 p.m. Central European Time. If you miss the live sessions, also from this week, which we had cybersecurity and space law, you can watch them. They're recorded on our channel. And don't miss next week's. The live sessions will be on engineering with a focus on robotics and photonics, and science with a focus on exoplanets. And they will be on Monday and Tuesday, respectively. So today we have a wonderful discussion panel. We have Christophe Lasseur, head of MELISA project and life support coordinator at ESA. We have Oliver Botta, scientific advisor at the Swiss Space Office. We have Théodore Besson, co-founder and managing director of Earth Space Technical Ecosystem Enterprises, SETEE, and Florence Loustalot, talent acquisition specialist at ESA. How the session would go, we will introduce each speaker and they will talk about themselves and their activities. And we invite you to ask questions through the chat in YouTube, as we will have a Q&A session after each speaker introduces themselves. We would also like to ask you to fill in the survey. It's in the video description with a link. And this way you can let us know if you would like us to organize more of these type of events. So now let's get started with the session. We start with Christophe Lasseur. So Christophe, could you tell us more about your career path and how you landed as head of the MELISA project, explaining also to the audience the life support activities developed at ESA?
Yes, good evening, everybody. It's a pleasure to be with all of you today and a challenge to explain you what we have been doing over the last 30 years in Europe related to the life support domain. So I ended up in ESA by first becoming an engineer, an electronic engineer who has a personal interest for life sciences. So I did a master in life science, and then I started to work in the industry, in the medical industry, where I was contacted by Airbus to join as an instrument engineer to study the difficulty to grow plants and specifically algae in microgravity. That was quite of a surprise, I must say, because I was far away from space and I had no clue that anybody at that time had any interest to grow plants or algae in space. I didn't see the link. So during that time, I did my PhD and I could join ESA as a research fellow later on. And after these 2 years of research fellow, ESA management thought that we should, let's say, increase the internal know-how or the European know-how in life support. And this was the opportunity to take the lead of MELISA project, which I'm still leading today.
Thank you very much, Christophe. I think you prepared also a little presentation also to introduce the activities of MELISA. If you want to share that with us, please. Thank you.
Okay, so all the objective of this presentation is to, let's say, give you... Okay, is that okay? Okay, so the idea of this presentation is to give you an overview of what we call life support and why it has some interest for space and for Earth. So the life support domain assumes that we have astronauts. Yeah, this is our customers, to simplify. So you see the current pool of these astronauts, and the little fat one with glasses is me, and the one with hidden behind me is, of course, a French astronaut, Thomas Pesquet, you may have heard of. And this is today the European astronauts which are regularly going to the International Space Station. Astronauts, such as humans, need to survive oxygen, water, and food, and this doesn't exist in space. To simplify, you are in vacuum. So far, there is no clear evidence that we can use water even on surface, and food, of course, doesn't exist. You cannot call Aldo Pizza to be sure that you will be supplied regularly. The astronaut has a normal metabolism, and he produces some waste as well. On Earth, you don't realize, or we start to realize, it could be a problem. But it's even more stringent when you are in a very close and airtight environment. What do we do with this waste? So today, the astronauts are rather close from the Earth, more or less 400, 500 kilometers, and we have cargo who supply oxygen, water, and food to the space station, because the space station is orbiting, is turning around the Earth. This is for the supply, and for the waste, we do it very basic. We more or less store everything in a cargo, and the cargo burns in re-entry. So this is not extremely sustainable, but it works, and that's the first thing that a life support system has to do. But we have big hopes to be able to go further on one day, to be able to quit the Earth's orbit, to return to the moon, to go to Mars, and at that time, if we pack up all these resources, oxygen, water, and food, within the rocket, it's too heavy. The rocket even doesn't start. So we do need to be able to recycle everything, absolutely everything on board the space station. And that's why probably today, space missions are still the best or the ultimate example of circular economy. So there is something that people doesn't realize as well, is that space vehicles are extremely tight, very small. What does it mean? It means that any contaminants, either physical, dust, either chemical, coming from material, coming from metabolisms, either microbiological, and these days everybody speaks about microbiology, but in a very close, confined environment, it will accumulate. You realize that the space vehicle is even more dense than any place worldwide. So the risk of contaminant is even bigger. So how do we do this? There is not one technology who you can use, you enter all the waste, and you will have food, water, and oxygen. This statement is not totally correct. There is one, it is the Earth. Yeah? But of course, we cannot push the Earth further to go to the moon or to go to Mars. So we need to duplicate the function of the Earth in a very small, in a very efficient, in a very tight, and a very low mass in order to be able to sustain the astronaut, and of course with a high, very high level of safety, because we want to bring back our astronaut alive. So Melissa and the Life Support, it's a big community in Europe. This picture has been taken on the border of the Lake Léman that you know quite well. And you see the community is somewhere around 300 people are working on life support in Europe these days. Yeah? It's a very multidisciplinary team. We have a physical engineer, we have microbiologists, we have cook, we have medical doctor, we have model expert, we have computer expert, we have plant physiologic expert, and all these people have to work together and speak together over more or less all Europe in order to be able to push this domain further on. It gathers as well a large number of PhD, and this is the Melissa PhD these days. They are generally funded by the Melissa Foundation. And as you can see, they are coming from very different countries. And we have even some invitees here in this picture from Australia who heard about Melissa and wanted to know more. This was during the Melissa Summer University that we specifically organized for the students every 2 years. So I was speaking about the Earth function, and this is exactly what we want to do. We want to duplicate this lake that you have on the screen and the function of this lake. At the bottom part of the lake, you have the waste, and progressively you go up to the top, and you will see different functions. We will progressively transform the waste in oxygen, water, and food. This is, of course, very complex, far to be controllable, But if you cut it in slides, as an engineer likes to do, and scientists, when they don't understand a problem, they try to study a little problem, then another one, and then they pack them all together in order to solve the problem. And this is exactly the approach of the life support system for the future. And this leg that you have here can be represented here as well. It's exactly the same principle. Compartment 1 is the bottom part of the leg, and you go in the direction of compartment 4, where you will have plant and algae, and here you will produce oxygen, water, and food. So this is a pure copy of the Earth ecosystem, but with a very robust and a very controlled strategy. And of course, when you want to do this, you have to understand all the process. You have to understand the bacteria. You have to understand the plant. You have to understand the chemistry. You have to understand if the astronaut will like the food or not. And this is part of the discussion. And you need as well to be able to simulate on computers to be able to be sure that this cycle, this virtual cycle, will work. And this is another representation of the Melissa cycle, where you have all the tools in order to be able to simulate the behavior, look for the risk, look for the drift, and see where you are in the process evolution. So how do we do this? We normally start in universities. We have a lot of PhD, a lot of research engineers who are working in the bench, in the laboratories of European site. More or less 12 countries these days, so very international once again. And then we go to more an engineering approach where you see this type of hardware, so really pilot case, a lot of engineering, works 24 hours a day, full year, several years. So everything has to be understood and controlled. This is very specific of the space domain where we need to understand absolutely everything to be sure that we are robust. Robust is a key word, and when you apply robustness to life science, it as well gathers new challenges who were not existing when we started this activity 30 years ago. And when you have done this at proper engineering level, then you are able to do it very small, because mass is the issue for space. And this is the same hardware, same function that we send to space to see if it works as we thought. And then you will have the opportunity to design the scale 1 system in order to be able to go to the moon or to the Mars. This is what we are talking about these days. But all this research for space, and you have to remember that ESA is a public organization, so we are paid by the European citizens. So this has as well a lot of interest for Earth. And today we clearly have a lot of synergy with the terrestrial challenges. You know that the environment issue is becoming to be a problem on Earth. So how can we use this technology to spin off or spin in the life support domain? So I just would like to give you two examples of what we are. This is a domain where we are active. Just wanted to mention a very famous tournament who ended up, I think, 2 weeks ago, where this all the tennismen and tenniswomen were taking showers, and all the water recycling of the tournament were recycled thanks to Melissa technology. So that was really a success for us. We were there for 4 tournaments in Roland Garros, so that really show you an example of water circulation and environment protection. And another one, which is in construction in Paris as well, in the south part of Paris, in order to benefit of light. We will have one of the first biofacade worldwide, which this facade is colonized by microalgae, in order to produce biomass, fix the CO2 which is accumulating in the city, as we know, and this biomass will be used for different possibilities, cosmetic, agro-food, fertilizers, bioplastic, and so on. So really it's producing inside of the city. Melissa is as well a very international place, and we now are experts in several domains, and I had the opportunity to be invited at the World Governance Summit. So you see there is opportunities of international decision as well if you join this domain. And I just decided to show 2 examples of young students who are, let's say, doing their career in Melissa. On the left-hand side, Pauline de Pape, who is Belgian, and on the French side, Lucie Poulet, who happens to be French. And they both did their master Melissa project, and they both decided to do a Melissa PhD. Yolene de Pape managed even to be cum laude. And Yolene has started a spin-off company today on urine treatment, urine recycling. And Lucy has recently joined NASA as a postdoc in the Kennedy Space Center. They, of course, have a lot of other skills. Yolene won the ArcelorMittal Prize, so it's a worldwide recognition of her work. And Lucy was selected for isolation campaign on Hawaii for the Mars Society and NASA. Just to give you the possibility that these two young ladies has managed to do. Yeah? So as a conclusion, the life support is today at the edge of physical science, chemical, and of course, life science. You really do need to have a very multidisciplinary approach. You cannot be only an engineer or only a scientist. This doesn't exist. You need really to be open mind, to be able to catch all the challenges, to be able to interface. You need as well to be able to gather different culture, talk with French people, we talk with Belgium, we talk with Norwegian, we talk with Italian. All this make it a very nice package in order to be able to progress. During many years, we really thought that the life support has interest only for space, and we realized that the challenge we are tackling for 30 years are now becoming more or less the same on Earth. And now really there is a big exchange with terrestrial community. As I explained before, Melissa actors are now becoming as well expert in a lot of different enterprises or in the different European Union projects, which I happen to do as well. It's today the unique worldwide project. Our American colleague, Japanese colleague, or Russians has no equivalent. So really, if you join Melissa or if you join the life support in Europe, you will be in a unique worldwide project. It's very, very international. As you have seen, there is very good opportunities for education and careers. And for those who are interested, the next call for Melissa PhD will be open in December this year. And on this, I will be very pleased to answer any question.
Thank you very much, Christophe. So the audience is now writing their questions in the chat. We'll give a turn to everyone to introduce themselves, and then we'll come back with questions. I'm sure there will be many for you. This was really interesting because you pointed out a very good aspect of the life support domain, which is multidisciplinary. It's not only biology and agronomy, but also, as you mentioned, physical, chemical, life sciences. But I would say as well, engineering, you have the mechanical and electrical engineering to build the bioreactors. I would say even computer science with the simulation. So it's a really multidisciplinary topic, which is very interesting. And of course, the topic of today's session. So we hope the students are watching and really interested in applying for the call in December. Thank you for sharing this with us. I would like now to introduce our next speaker. He's Oliver Botta, the scientific advisor at the Swiss Space Office. Oliver is working at the State Secretariat for Education, Research and Innovation in Switzerland. And could you give us a big picture of the space activities that are happening here in Switzerland at a national level? And of course, if you could add a bit of your background on how you landed at the Swiss Space Office, that would also be very interesting to know. Welcome, Oliver. I think Oliver is having a bit of a trouble. We see the presentation now, but we're not hearing you, Oliver. Let's wait a minute if it comes back.
Hello, do you hear me now?
Yes, now we hear you.
About
Perfect.
That. Yes, sorry. Yes, so I'm having trouble with my video, so I will show you the title of my presentation. So yes, my name is Oliver Botta. I'm working at the Swiss Space Office, which is part of the State Secretariat for Education, Research and Innovation, in German Staatssekretariat für Bildung, Forschung, Innovation. Yes, my background, I have a PhD in chemistry from the University of Basel that I had more than 20 years ago. And then I spent almost 10 years as a researcher in the United States and in the Netherlands, where I worked on in astrobiology. I was investigating meteorites, organic compounds in meteorites, and I was also involved in space experiments, instruments that would fly to Mars to actually look for organic compounds. So that was the plan. So the plan was then to go into a academic career, which in Switzerland is a bit difficult because the air is quite thin up there. And eventually I ended up at the Swiss Space Office, which is the competence center for all space activities in R&D in Switzerland. And so today I am a delegate for Switzerland at a number of boards and committees at the European Space Agency, where I represent the Swiss interests, which is also a very interesting job. It's not directly linked anymore with science and engineering, but having a science background certainly helps in these positions. But of course, you learn a lot about politics. You learn a lot about diplomacy in addition. So I think and I've been doing this now for 12 years. And I'm not tired of it yet. It's still very interesting, very new projects on the horizon, which I will talk about in my presentation.
Thank you very much, Oliver, for the introduction. It's really nice to get to know also that part of your background. Yes, if you would like to go ahead with your presentation, we are very happy to see what you prepared.
Okay, thank you, Tatiana. So I will give you a short overview about Switzerland in space. Many people are not even aware that Switzerland plays a significant role. We are a spacefaring nation. Some of the students watching this program may not even recognize the person who is on the presentation here. It's Claude Nicollier. The first and so far only Swiss astronaut that we had, and this is a picture from his last shuttle mission, where he's made an EVA to service the Hubble Space Telescope. So in principle, what the message here: space is cool. This is what people see, when they think about space. It's astronauts, it's going to the moon and things like that. But I want to show you that there's much more to it. If I can switch my slides here. So just maybe a quick view of where it all started in Switzerland. The University of Bern celebrated last year 50 years of the lunar landing, and we celebrated that with them. And the reason was that one of the first experiments that was ever put on the surface of the moon, the first one, is actually from Switzerland. So so this is kind of what we call the origin of Switzerland in space. Of course, we don't do this randomly, but there is a Swiss space policy that is in place since 2008, and it has three main pillars: activities that are linked to the development and utilization of existing and future space infrastructures to improve the quality of life of our citizens. So things you can benefit from in terms of navigation, in terms of telecommunication, in terms of weather forecasting, etc. That gives us that you benefit from. We invest and you benefit as a citizen. The second one is linked to science and exploration, where we have a very strong role in Switzerland. And you can see a picture on the right side of the Cheops telescope that launched at the end of last year. Here's in the integration hall in Ruach in Zurich, and then of course we want to be Switzerland. Also, what we do when we are on the Earth and not only in space is we want to be a competitive but reliable partner to all international partnerships that we enter into. and we want to have a competitive industry. And on the bottom right, you see an example of where Switzerland is contributed a lot. It's one of the fairings, the top of the rocket of Vega. That all these fairings are built in Switzerland since many decades. And the trailer on which this fairing sits is also a product coming from Switzerland. And this is a picture taken in French Guiana at the Centre Spatial Guyanais, where the big launch base is for Europe. Primarily, Switzerland safeguards its national interest via selective European and international cooperation, primarily in R&D, in the R&D area through ESA, but of course also we participate in the EUMETSAT organization. We also contributed and will hopefully contribute in the future in all the EU programs that are linked to space, and of course also on the regulatory level at the Committee for Peaceful Uses of Outer Space at the United Nations. So ESA, probably Florence will make an introduction later on, but just to a few bullet points. ESA is an independent intergovernmental organization. Is not linked to the EU at all. It has today 22 member states and 3 associated states in Canada, Slovenia, and Latvia. And Switzerland is a founding member, from the 1970s. And we had a recent the success with the co-presidency from 2012 to 2016 that we had at ministerial level. Together with Luxembourg, and on the budget, maybe I leave that to Florence. But the important thing is that what you need to understand is ESA is doing a lot in space. It's not only about astronauts. It's not only about space science instruments. It's everything. You know, it starts with launch vehicles, telecommunication, navigation, Earth observation, monitoring, science, technology, and operations. It's a whole spectrum of activities that ESA is doing, and of course there are lots of opportunities for careers for young scientists and engineers to pursue at ESA in all these domains. And I guess Florence will talk about this in a bigger extent. So why is my slide not ching? Sorry. Oops. Can you still see my presentation? Oh. Sorry, my PowerPoint just quit. See if this is my last one. I'm sorry. Need to restart.
We don't see now your
yes, hang on.
sharing.
Okay. Yes, sorry.
It happens.
So I need to reshare my, just give me a second.
Exactly, yes.
Yes. You see it now?
Perfect.
Okay. So, sorry about that. So everybody's seen now my screen. Okay. And the point is, you know, space is not only space in a direct sense, but of course, space is also linked to many other emerging themes and trends that are, you know, we all observe worldwide, and there are certain links. Big data is an example. Cybersecurity is an example that we talked yesterday. Globalization, competition for talent, all these things where space can contribute and contribute also questions to climate change, for example, and questions to big fundamental science questions on the origin of life on Earth, etc., etc. So it's a very broad and very expensive areas of where space can contribute, and where you as a scientist or an engineer can contribute to resolve these issues. Maybe a few words in Switzerland. Who are the actors that are mainly involved? So we have a number of academic actors, ETHs. We have the universities that are participating, especially University of Geneva, Bern, Zurich. We also have a few research institutes like the CSCM or the PMOD in Davos. And we also have now a few Fachhochschulen that are participating as well. And we had recently the first instrument that was developed by a Fachhochschule, the FANW, launching on Solar Orbiter, the STIX instrument. And there's a wide variety of companies in Switzerland as well, not only now for life support, of course, and Theodore will tell you a little bit more about that later on. But there's big companies like RUAG, APCO, and others. But many of the companies are actually SMEs in the areas of electronic, mechanics, engineering, etc. And here also research institutes like EMPA and ERWAC that are involved in more specifically on life support. So there's a big Swiss space ecosystem that exists, so more than 100 companies. And maybe specifically, maybe I want to bring up one point because I'm in the exploration. So exploration, of course, is we go beyond the International Space Station. This is this famous gateway that NASA and ESA have yesterday signed the MOU together, to the agreement to collaborate on this project, which is a small space station around the moon. And you see ESA will contribute the few elements, the refueler element, the communications element, and the habitation module. And of course, we also contribute the service module for the Orion spacecraft. So also exciting opportunities for European industry and for European scientists. And this will all happen in the next decade. And then maybe a final word I would like to say also, Tatiana has worked on this a lot in recent years. Opportunities for students to be involved in exploration, going to the moon, is of course this Igluna project that allows students from all over the Europe to participate in this project. And then we had the first Igluna habitat in ice in 2019 at Matterhorn. And there was a plan to do one in 2020 as well, which was, I think, a virtual one. And now the plan is to do another Igluna next year on the Pilatus, with a link to the Museum of Transportation, to the Verkehrshaus in Luzern. And so there's a good opportunity if you're interested in these kind of activities to maybe join one of these or participate in one of these activities, propose something. And of course, life support is exactly something where there has a strong link to that. And I think I will close with that. Again, apologies for the technical problem. Just another cool view of space and launching satellites. Okay, thank you. Sorry about the delay.
Thank you very much, Oliver. It was really nice to have the general big picture of Switzerland and what we're doing for space, which is not maybe known by everyone outside Switzerland. And thank you also for bringing up Igluna. I'm really happy you brought it up. Actually, every edition we're growing and growing. So far we have more than 20 universities that have participated. And yes, we're looking forward to this year's field campaign, hopefully in July at Lucerne, like you mentioned. if people viewing are interested to learning more about this project, which is also a good idea for students who are interested in getting into space activities, please visit our website. We'll put it in the chat so you can learn more about the Luna and hopefully future editions of this ESA Lab at CH activity we're coordinating at the Swiss Space Center. So we'll move forward to our next speaker. Thank you, Oliver. We will come back with questions in a few minutes now that the viewers are writing in the chat some questions for you as well. So now we will introduce Théodore Besson. He's the co-founder and managing director of Earth Space Technical Ecosystem Enterprises, ESTEE. And well, Théodore, now that Oliver gave the general introduction on the Swiss space activities, could you detail more on the actors working on life support systems here in Switzerland? And also, of course, tell us about your experience, what you study, and how you became actually to found your own company. That would also be very interesting to know for our audience. Welcome, Théodore.
Hi, everyone. Good afternoon. Thank you, Tatiana. Thank you, Christophe and Oliver, for the great talk. Yes, so indeed, I believe it's a good moment to introduce how at ST we are finding our place, trying to innovate at the crossroad of terrestrial and space dimensions of life support system development. And yeah, to start like the other. Little bit about myself first. So I'm trained as a biochemist from the University of Lausanne. I then pursued a Master of Advanced Studies at EPFL in Environmental Management. And for some time, I was a researcher at University of Lausanne with a great project, the so-called MELISA project, working on and trying to see, assess the relevance and the contributions of the research related to manned space mission, typically mission to Mars, the contribution to sustainable resource management on Earth. And during this period, we had the great opportunity to join the MELISA consortium. And at that time, in 2013, I indeed had the possibility to co-found this startup company, a spin-off company of MELISA, in a sense, more at the level of the operationalization of the conceptual work. So in a nutshell, what could be the research agenda within LSS demonstrator for preparing a Mars mission? Let me switch to the next slide. So this company, ST, its vision is really about fostering the exploration of human in space. And for this, making sure that we would provide to the crew closed habitats that are both sustainable and also comfortable for space, because the environment is so harsh there, but also with Earth-based application. So we need for this technical solution integrated in mini ecosystems, because you have to deal with the very hostile environments in space. And if you want to succeed in such venture or adventure, of course, absolutely to make it possible to partner up with many enterprises and other organizations. So to put this vision into action, it's again all about recycling, as Christophe introduced. So we have to transform waste, typically human and organic waste, into valuable resources, so that almost nothing would be lost, but rather valorized. So it's, as Christophe said, it's all about scaling Earth. So you have to miniaturize the biosphere and simplify it. So this LSS system that was introduced by MELISA is really like doing this material loop closure with this human waste that is degraded by this microbial reactor, and then providing nutrients to plants that will regenerate oxygen, provide food, and also partly produce water through evapotranspiration. And this is, again, it's important. What matters here is really to minimize the mass to be taken from Earth to make the mission economically affordable. there is this MEDISA pilot plant in Barcelona, but today the crew is rats, right? And there is some time before a ground simulator would take place. So here in the slide, you can see the FIPOST ground simulator. It's the future to the right side. It's the future ESA ground demonstrator. Or any other international effort for like preparing with human on ground such mission, and it's going to be the next step of the MEDISA pilot plan. But today there is a missing demonstrator, a closed habitat with human. So at ST, the objective is the road mapping of the SPX series, as we call it, that is a demonstrator with limited and reduced technology readiness level, but that can make it possible to experiment and to do research campaign on Earth and to fill a gap. In the meantime, the MEDISA pilot plant become a space agency ground simulator. So to the same extent that MEDISA is doing for decades, we are trying to have a design for minimal closed habitat, really a minimal for comfort, for habitability, and with maximal recycling features. So we did the preliminary design completed some time ago, and to give you a few high-level specification on that prototype, it's designed for 2 crew members, for self-sufficiency, for long duration mission. And to give you an idea, it's 1 cubic meter of consumable that we could pack inside the prototype to then be able to do a 1-year mission with the material loop closure as high as possible. So we are trying to do as much as possible planetary base orientation and inspiration. This is an indoor prototype, but we do it as if it would be Mars compatible for the life support system technology inside. So this Scorpius prototype 1 or SP1 was designed to become a world premiere, a proof of concept of a closed habitat demonstrator. And our role is to identify, select, and integrate existing life support system compatible technology and interface them. That's the main challenge. By doing so, we participate and enhance the preparation and the financing on Earth of manned space mission. So we try to have a complementary role and a facilitating role. So our technology readiness levels are more between 2 and 5 as TRL, and depending the module. And one of the key challenge, one of many, but here, of course, we have to deal with a limited budget in times and money. So it's a big adventure. We've got many prototyping topics and areas, typically for smart food production system, like decentralized waste treatment system, water production. The habitability is our example of the kind of application you need to integrate. And it's very diverse, and are available also for Earth. So for several kind of application, typically in urban context, in cities, in like music or cultural event, in hotels, or to Christophe gave the example of the Roland Garros tournaments. And there are also lots of application in developing countries with low-tech version of those technologies. So LSS technology are useful for when ecosystems are suffering from resource shortage or pollution. And of course, LSS with the space on Earth, with the space analogy, is useful for dealing with confined, remote, and isolated or off-grid habitats. Again, I believe that we have to say that the COVID sanitary crisis shows the importance of the life support system technology for the remote health monitoring, for the microbial safety and air quality as examples. So to summarize, the position of the company that I create is to play to act as a catalyst at the crossroad of space and terrestrial dimension of LSS. On the left side, you've got all the Earth-based application of LSS with the capacity to empower self-sufficiency in demonstrator on Earth. And then in the middle, you've got the ground demonstration for the manned mission to Mars, and with the perspective in the horizon to have the space LSS for human space exploration and possible settlement happening in the next decade. Those applications are like showing a very clear potential for circular economy, as Christophe also mentioned, because it's the concept of circular economy very popular for policymakers, but with LSS, you are really having the opportunity to implement, put that into action and operationalize. That's very interesting. With LSS, you depend on actor along the entire value chain of innovation, not just R&D and tech transfer, but also industrialization and commercialization. We have to say that despite this great potential and high potential for terrestrial application that was mentioned, currently LSS solutions are, some, not many of them, are still at the early start for the industrialization and commercialization phase. This is actually an opportunity for you that are attending this session, because there are lots, there's a lot of works, and lots of innovation is needed. And to innovate, you need to execute. And for executing and really putting that into action, you need a business mindset, and you have to enable this this LSS market. You have to make it real and to impact with products that are well defined at the development. So in this framework, education and participation of public, but also young people and students or young experts is absolutely crucial. And as you understood, the financing of technology demonstrator, because they are like having this multi-techno, is key but costly. But it's needed. It's a first step then to attract new investor and private investor. So if you are looking for a great job in closed life support, Oliver also gave the big picture and the mapping on the key actors in the field. We recently submitted a paper that was giving an idea of the current state of the cluster of organizations that are connected to ESA and to life support. And it's really broad, and there are many collaboration opportunities to explore for finding a great job. So it's not just research institution like UNIL that is a member of MELISA, or EPFL or EAVAG that is having together with ETH Zurich also a PhD that we are trained within MELISA. It's also other like Fachhochschulen with Lucerne, with Zurich, Swiss Applied University, to cite just a few. And it's also companies like, of course, RUAG, SERI, indeed, and UNICEF, for instance, that was a startup incubated at the ESA Business Incubator recently. But you've got also terrestrial parties like VUNA, that is like dealing with urine valorization, a spin-off from EAVAG and ETH Zurich. You've got Surface, InnoBridge, many players that are fostering this development. So as Christophe also mentioned, there is this big community, this teamwork, this team effort, activities at international level. And the MELISA workshop was hosted in Lausanne in 2016. By coincidence, just next week is the next MELISA conference. So you see the very interesting broad range of topics related to LSS that is, it's still possible to register. So you've got all these organic waste treatment system, the urine treatments, the water recycling, the edible food production, biomass production, modeling, ground demonstration, terrestrial application, lots of topics related to life support. It's a must see, a must participate, if I may say. Voilà. So don't wait to get engaged if you want to be a star in the ESA universe. And for this, just a few words on, for instance, initiatives or courses that we are offering at SETE. and UNIL. For instance, by giving lectures at EPFL, there is a very nice teaching unit for 10 years that is happening at the School of Architecture, Civil and Environmental Engineer. So we make a semestrial course for students to integrate the Martian constraints in the design of a planetary base, in order also to have a material loop closure happening, in situ resource utilization. And here you can see a few of the rendering of the students. Oliver mentioned the Igluna initiative that started in 2019, the ESA lab, that was coordinated by Swiss Space Center. So just an example, just two examples with this robotic greenhouse called the Grobot Hub. It's an interesting project because it was not over after the Igluna the 2019. It's still pursued at EPFL, and also many students, maybe some of you are participating to those projects. So it's interesting to see that you can have like a long-lasting project and also multi-organization, because it's not just EPFL and UNIL, it's broader. And we also involve our students at EPFL from this teaching unit I just mentioned, so that the students are not just designing, but also participating to the manufacturing and assembly. And you can see on the bottom right picture that we even had VIP visiting the prototype with Christophe coming at EPFL. More happening right now. So there is this Asclepios mission that is scheduled in February 2021. We hope that everything will be good also for this one. So you can have the opportunity as student to participate to an analog mission for Luna or Mars mission, and with a 1 week closure in here the Grimsel testing site in the middle of the Alps, and you see the students doing some rehearsal in a command in the control center here that was for testing the suit. So my message would be, as students, you should obviously get engaged as early as possible. But there are many opportunities. So semestrial project, bachelor, master level, student project, internship in private companies, and later PhD, postdoc, everything. Of course, all practical experiences will become an asset for you. They will make the difference if you aspire to do whatever space-related job. It could be at ESA, but it could be anywhere else in research institution and private companies. There's a big momentum happening for broadening the LSS community with new actors, new people, and this is happening also in Switzerland. If among you are like expert or professional from non-space sector, you have, we hope that you are now convinced that you can consider LSS as a topic for you, with real opportunities to get engaged and match your non-space competencies with a space-related field. That's something very interesting. So it's not just engineers, scientists, and researchers, it's also innovators and managers that are needed for this spin-out and spin-in of technical solution, and this cross-fertilization of both space and terrestrial dimension of LSS. So some very final thoughts for ST and for other LSS players. A challenge often comes from a certain level of mistrust on the importance of human presence in space because of the climate change, because of some urgency on Earth. I do believe that human space exploration should be considered as a topic of the utmost importance, and very notably due to its value coming from space LSS technology that are very, very elegant, in my sense. So clearly, working in a sector related to space is just fascinating, and it's even more inspiring when it can become beneficial to terrestrial sustainability. So space LSS are drivers for eco-innovation, and the very value relies on the capacity to deal with very limited resource, to do this integral recycling as much as possible, which can also improve life on Earth. So this is actually what LSS demonstrates. So with this, I have one more thing. Of course, at ST, we are welcoming, we are offering engineering job opportunity, internship, unfortunately, no application is possible, but very soon, later this year and early next year, there will be a new recruitment phase. So I look forward to welcoming your proposition. With this, thank you very much, and let's collaborate together.
Thank you very much, Theodore. It was great actually hear you talk, and you're very passionate about this topic. So it's really great, and it's something that students should be inspired also to be passionate about the things they care about. As we saw, it's not only a space application, life support, and like you mentioned it and highlight, it's also for terrestrial applications. So that's very good, something that we need to create a better life here on Earth. And also very good advice on this, what you gave for the students to get involved as early as possible with their bachelor, master projects, PhDs, just to be more active if they want to work on the space sector, to start doing projects on these and don't wait until they land in a job position later on. So just to do as much as they can while they can. And yes, it's really great to see the activities you're doing at SETE also as an example of a fruitful outcome of what came from the Melissa program. So it's great to see that it's really a positive, giving positive results. Thank you for this presentation, and we'll have some questions for you in a few minutes. We'll introduce first our last speaker of this evening, the juicy part for the students that are wanting to work at ESA. So we have today the honor to welcome Florence Loustalot. She's a talent acquisition specialist at ESA. So Florence, could you tell us how students and young graduates with ESA member state citizens could apply for a position at ESA, and any advice you might have for our viewers as well?
Yes, thank you. Good evening, everybody. Thank you, everybody, for the very interesting presentations. And I think the one I'm going to make now will a bit, let's say, conclude on what we have heard so far. So before I start to tell you a little bit about all the entry-level and research programs we have at ESA, I also would like to say that there is not only one way to arrive at ESA. And if you are a student, if you are at university about to graduate, you may start to, let's say, to make an internship in industry and then come to ESA, or come to ESA and then go to industry. One thing is sure is that your interest and motivation and passion will be always very important in your career. In 2 words, I'm not going to tell you about my CV, but just in 2 words, I studied languages, and then I did a master in business administration in HR, let's say. But I didn't think I would work at ESA. So, you know, I started as a, let's say, teaching French in England, and then moved to Germany, and then to Italy at the Food and Agriculture Organization, and then the European Southern Observatory in Munich, and then ESA finally. And here I've moved in several establishments and in various roles at HR. So a career is really a succession of steps, and there is always a logic, as I say. And this logic is what you like to do. And that's the most important message I would like to pass tonight. Now, to start, therefore, with our programs. So I will start with the student internship program, because it's the one which addresses the students who are in their last year before the master, or the penultimate year before the master. And it's an internship for 3 to 6 months. We are going to publish our opportunities beginning of November. Something like 100 topics will be published. But this year, in view of the situation we all face, while we wanted to keep our program alive, we have to have only remote internships. So that's very important for our students to know that. But I would strongly advise that they consult the website of ESA, as from beginning of November, the opportunities will be open for 1 month. And they take place, let's say, with the tutors and colleagues in all ESA establishments. Okay? So that's for the student placements. Then we have the program of the young graduate, which is very well known for the students who are about to graduate or just graduate. To be part of the young graduate trainee, and apart from being, let's say, a citizen of our member states or of our cooperating states, European cooperating states, or associated member states, or Canada, you must have your master. This is really a condition sine qua non. And this is a one-year contract, sometimes renewable, for a second year. During this young graduate traineeship, you will make your experience tutored, accompanied by ESA experts. You will work in team. You will work on exciting and very interesting projects. And I will speak later on about the profiles that we have for these young graduate traineeship programs. Next to the, and very important, I was about to forget, as in the past, we were publishing, while we were publishing in November our opportunities, this year we will publish in February 2021 for a recruitment in September, October 2021. I already said yesterday, really note it down in your agenda. It's very important. And it's also written on our website. The opportunities will be something like 100 opportunities published, again for 1 year, for 1 month, for 1 year contract. So take good note of that. Together with the YGTs, we have another program which is called the National Trainee Program. So the profile of the National Trainee Programs is the same as the YGT. The only difference is that they are not recruited really by ESA, but by the national agencies, with which ESA has an agreement. So we have at ESA, for 1 year or 2, we have some Swiss national trainees who come for an experience, and they are selected by the Swiss Space Office together with us. And they make their experience, and they really work together with the YGTs, together with the fellows, the students, the experts. So it's a very huge community, very dynamic community, I must say. As you see, we have a few programs from Belgium, Estonia, Germany, Ireland, Luxembourg, Portugal, Switzerland, last but not least. So that's the National Trainee Program. We also have a program which addresses more specifically the ones who have a PhD. So the Research Fellowship Program is for people who already hold a PhD or are about to get it. And it's a program for 2 years with a possibility of renewal for 1 year. In this case, it's more about research related to space science, space applications, and technology. Okay, most of our research fellows are imposed in ESTEE in the Netherlands, or in ESAC in Spain, or in Italy, or in ESOC in Darmstadt. Another program, which is the latest born, as I say, used to be known as NPI and is now the ESA co-funded research program. It's a program which is a little bit different in the sense that it's not completely managed by HR, but it's a program where you have a full, real, let's say, cooperation between university and ESA. And it's let's say for people who want to make a PhD or already have a PhD, and the research is co-funded by ESA and university. I note the website also there, ideas.esa.int, because you will see a bit the particularity of this program, but everything is written there. So please don't hesitate and consult, let's say, the website. Now, what are the kind of profiles that we need and we look for at ESA in general, but in particular today I'm talking about YGTs and research fellows and students. Already Christophe and mentioned it before in his team, which is a very diverse team in terms of background and disciplines, also educational background. We are looking for mechanical, electrical, system engineering, software engineering. I mean, all the disciplines in engineering you can imagine, you can find also in ESA. Then we also, of course, look for scientific disciplines background, scientists profile in Earth observation, geophysics, meteorology, in planetary and space science, astronomy, astrophysics, solar physics, but also in life and material sciences. Now, beside this, let's say, technical, let's say, disciplines, and which really respond to the core business of ESA, we also have business and administration disciplines, because of course you also need people who don't have an engineering background, but more an administrative and business background to, let's say, occupy the positions in law, finance, communications, public relations, HR, but also, and this I could have mentioned maybe before, in IT. IT is also a very important discipline and will be also in future. Maybe if you hear the first session, you will, the ones who are interested, you can hear that already. Again, what kind of profiles are we looking for? Beside the education, master's, PhD, we are really interested in recruiting people with a passion, people with team spirit, people who are curious, who want to learn, who want to grow, who want to discover, and who are happy to work in a multicultural environment. I like to often mention the notion of pleasure in work, because if you have pleasure, you will do better. That's something which I believe is true. So when you think of what you like to do, then go for it. Diversity, I've mentioned it already in the difference in the background, but also in the geographical backgrounds, in the gender background. So all aspects of diversity make a team successful. We should look for people who are different than what we are to build a good team. And I think also this we have heard before in the previous presentations. So I am sure you can read the slides, so I'm not going to do it. I will go to the next one, which gives you our address www.esa.int. And I am sure that we may have questions which I can answer at a later stage if needed. Thank you very much.
Thank you very much, Florence. It's really nice to have the overview of the opportunities at ESA that the students and young graduates have. And there's actually many questions coming up, not only for you, but also for our other speakers. So I would say we start again with the table. So with Christophe, just to give again the chance to everyone to speak again, and with some questions we have coming up from the audience. So Christophe, for you, there's this question for the PhD call that you announced. Does the Melissa project only need scientists, engineers studying around chemistry, or you also need other fields like aerospace, for example?
No, of course, aerospace engineers are part of the profile we are looking for. I mean, one key objective of Melissa is to fly. Yeah? So we need aerospace engineer as well.
Thank you. That's good to know. And there's another question. They're asking, when will Melissa systems be ready to use in a spacecraft or space station as a life support system?
We did already. Probably we didn't publicize enough. We flew already a photobioreactor, which is more or less, to simplify, algae culture 3 years ago. Yeah? And we will refly again an oxygen producer, which called Artemis C in 2022. Let's say the precursor of a urine treatment in 2022 as well. And the first plant cultivation and then the roots problem, which is planned somewhere around 2022, 2023. So we do flight, and this is clearly one of our mandates.
Excellent, because they was also asking if you cooperate with ESA, so I guess this is now answered. What about the gateway? Are there any plans also to collaborate with them?
But of course, ESA is part of the gateway. As mentioned by Oliver before, the collaboration has been signed yesterday. So we provide several things. One of my colleagues is involved in the life support domain, but clearly the life support domain of Gateway is not a revolution. This is a short missions. So it will be very much Apollo inspired, limited recycling. Now we are more focused on, let's say, using space station in order to prepare the Mars mission, which is called ISS for Mars.
Great, thank you very much. Now we have actually for Oliver Botta another question now to the round table. And they're asking, what would the life support activities in the space domain look like in Switzerland over the next few years, if you would have a prediction of what would happen? Oliver, are you around?
Yes, I'm here. Sorry, can you repeat the question? I'm not sure if I fully understood.
Yes, for sure. What would the life support activities in the space domain look like in Switzerland over the next few years?
Well,
like a forecast, maybe, if you would have.
It's difficult. Nobody has a crystal ball. But I think what Théodore also referred to in his presentation is that we tried before the ministerial of 2019 to bring together the very diverse community in Switzerland on Melissa and life support, to grow and to better know each other and to collaborate. I think fostering collaboration is one of the important points, and this is in line of what we try to do, is to establish a bit more clusters of the different themes within Switzerland. And I would like to mention that, of course, the funding coming from ESA is only one source of funding that could fall into, could flow into Melissa and life support activities. Due to the diversity of these activities, one could also imagine, private investment. One could also imagine contributions from the Swiss National Science Foundation, etc. So I think it's one of the interesting elements and parts of Melissa, and this is that it's a very diverse community and with a very diverse set of objectives. You have industry, you have research institutes, you have terrestrial applications, and you have, of course, the space part, and the space part is only a small part of it. And so we hope that this community continues to grow and continues to collaborate to reach a critical mass, where we then gives us more opportunities also to ask and to our authorities for more funding of the space part of life support system and Melissa activities. So far, this is only growing very, very slowly. Of course, there are other priorities, as I said before. The space is not only astronauts and the gateway and etc. It's much more, and we have to consider all kinds of interests, space activities in Switzerland. So it's always a balance of interests that we have to take into account. But I think the community is there. It's very interested. It provides high quality products, and so I'm optimistic that we can continue on a growing path.
I agree with you, and I also hope we get more opportunities in the next few years as we keep growing on this domain. And yes, hopefully, like you mentioned, also in collaboration mindset between industry, academia, and all the different actors. Thank you very much, Oliver. We now move on to Théodore for another question, actually concerning your presentation. Someone noticed that you said that young students should be educated or learn to get an entrepreneurial mindset. So do you have any suggestion on how this can be accomplished?
Yeah, so it's not the only skill that has to be cultivated. It's maybe not the starting point. It depends, and it depends your way of like projecting yourself in your career, or if you're which kind of innovation course is offered at your university or whatever school you are trained. But yeah, most of the time it's clear the ideas, inventions, if especially if they are in the field of LSS, they will be first based on a technical know-how or on a specific technology. And then the business mindset can be cultivated. So if you have the opportunity to do that within your study, it's even greater. But I'm also addressing this point for the young professional, by the way. So sometimes you have the opportunity, you have to be curious. There are like many opportunities to get trained as an autodidact, but also through your study. So there is always a speech, a talk, like you are following this session for your career. So you are curious, you are looking for ways to be life support, but there are tons of opportunities, especially talking to the Swiss audience, because this I know very well, but also in Europe, I guess, and Melissa in general, there is more and more like possibilities to get informed, to speak with startuppers or speak with students that have a side project that is going to become a startup or whatever thing that will then be learning by doing. I mean, it's really there are many possibilities. But to bounce back to an example that we that was introduced with this robotic greenhouse, the students that had that idea that was then integrated to Igluna was not aimed for space first. And they won an award with one of those, you know, maybe the hackathon. So it's like one of those like short duration events where you have to do a potential business idea, and they won it with a greenhouse that was automated or something like this, and then it became a few years after the Botta that is now then more. There is like it's a sort of spin-off project of the initiative that was awarded. Otherwise, there are these citizen lab in Lausanne area. There are several of those citizen lab where you've got your idea, but then you have also you are in an environment that is promoting this this business mindset or innovation implementation. And just for EPFL also in UNIL, there is also this mass challenge, like event. There is a lot of support from the innovation agency, also for students, for young professionals. There are great books. Maybe you're aware or familiar with business model generation. That was coming from UNIL, huge success, like for just one example. So there are many ways to do this, but in the framework of LSS, it's very nice because like this recycling technology, they have application in a broad range of yeah, many location, many kind of sector of activity, and for developing country or for urban context. So it's very diverse. So it's a little bit up to you to participate to lecture seminar at your school, and most of the time I believe today there is now innovation that is integrated. It's a little bit like sustainability. Now, sustainability or innovation, normally it's integrated to part of the study. And maybe a final thought, like some 10 years ago, these projects and these opportunities, they were not existing, simply not existing, not just for LSS, but also for like this capacity for students to develop, to implement their ideas. It was existing, but not to the same extent, in my opinion. So I hope to have given a few thoughts on that.
It's great advice, actually. Thank you very much. I hope with this we can trigger some young entrepreneurs who want to maybe found a startup also, as you did in the life support field. Let's see what comes up in the future. Hopefully also, like Oliver mentioned, that we keep growing in this direction. To close now, maybe the Q&A session, I would give a couple of questions to Florence, which was a lot of questions for her from students that actually want to apply to ESA. So the first question we have is if you need an official qualification of engineer to join ESA, or can just any engineering degree be enough? Is it a PhD is a plus over a master or not? Is it required to do a PhD? Or?
Okay, thank you very much. I will try to answer the two questions. So the first one, what you need is a master or an education at master level, equivalent level. So if you have studied in an engineering school and your diploma as engineer is the level of a master, then it's okay. Okay. You have the Bologna process. You can also look the equivalence, the credits. So that's one thing. On the question, is a PhD a plus? It depends what is the let's say the area where you want to work. If you apply to a job as scientist, researcher at ESA, by the way, we have 10 positions open at the moment for research fellows. Therefore, there you need a PhD. But if you apply as a young graduate for a position as system engineer, mechanical engineer, you don't need a PhD. What we look for is your education in engineering. Okay, so it's better if you focus, if you have a PhD and you want to work at ESA, look at the positions we open for internal research fellows.
I understand that. I hope that's clear also for the audience. And another question about the conditions to apply, if they're asking if they have two nationalities, which one is from ESA member state, but one is not. Is that okay to apply?
Yes.
ESA? Yes.
What is important is that you have at least one nationality of an ESA member state or associate member state or a European cooperating state.
And what advice can you give to people who want to engage in space field in Europe but do not have a European or ESA member state citizenship?
I would tell them that maybe if there is a national space agency in their country, they can contact them, who then can also give them advice. And that's the best. That's for me the first answer which comes to my mind now, because at least they can also relate them to other possibility, to industry, to other possibilities to make a career in space in general.
That's good.
As national agencies can be in touch with our international affairs, our office for international affairs, and maybe there can be a possibility.
Okay, I see. That's good to know. And also talking about advice, what advice can you give to experienced professionals? So not only young graduates are watching us today, but experienced professionals who never work in aerospace industry and would still love to join ESA or the space sector in general.
Well, again, I would say the same thing as for the youngs, is that in fact, the main thing is to consult our website. Okay, and there, if you, it's very mechanic what I'm going to say, but if you set up an alert, you will receive our job offers, and you will discover we have a lot at the moment. I think we have something like 50 at the moment open. You can see if there is an opportunity which corresponds to your profile and your interest. It's not because you may come from another kind of industry, which is not the space industry, and have a profile which is also very much interesting for the space industry or for ESA. You may have, first of all, again, an approach to work, new ideas, a profile which is innovative also for us, and also technical skills which are interesting for ESA or for the space sector. So for me, the most important is check the website, look if you are interested, if you feel attracted by this area, look at the job offers, and if you see something you feel attracted by, apply. Don't decide yourself that your profile is not good for us. Let the recruiter do that. Because
that's a good advice. Yes, that's good to say it out loud.
But also, yes, go ahead. Sorry.
No, it's okay. I was just complimenting, but yes.
No, go ahead. No, I wanted to give one or two advice for the youngs if there are no other questions. But if there are other questions for my colleagues, then go ahead. Also.
No, but perhaps also a last one for you. As you mentioned, the national trainee program and in different countries around Europe. Is there a deadline when they're released? Is it also in February, or they're asking, is it depending on each country?
Yeah. Yes, this is depending on each country. I mean, in fact, it's the country who decides when they are going to publish the opportunities. I have, in fact, it's more in the spring time. Spring, summer, and in fact, we have done all the interviews in the spring and in the summer, and now we will recruit a few new national trainees in the autumn, winter.
Oh, and it's usually in the website, so they can check the website.
Again, on our website, even we have a page for the national trainees with the link to the national agencies who have opportunities.
Excellent. Yes, so if you would like to close with your advice, and then we'll maybe go a quick round and ask everyone if you want to share the email address. Also, if there's more questions for ESA Human Resources.
No, the advice I wanted to give in general because we also spoke about that in the previous sessions, and I think it's quite important, is indeed look well at all opportunities that we are going to publish, be them the students or the YGTs. Read them carefully, select really the one which is let's say, attracting you, which you have an interest for, which is also, of course, in line with your background, and prepare well your motivation letter and your CV. Remember that this is your first contact with your future employer, be it ESA or industry. We read your motivation letter. We want to understand a bit who you are and what you like to do. So be direct, concise, and clear. And if you are selected for an interview, please prepare for it. Prepare on who you are, what you have done. We know that often you don't have a lot of experience before. You may have internships and your studies. This is very important. And the sports you like to do, the activities, the hobbies, who you are. And prepare also on the employer, like be it ESA or another let's say, employer. If you come to an interview, you have to be prepared. That makes a difference.
Thank you very much, Florence. Yes, that's a great advice. Wondering, I think there's a bit of background on my microphone. I hope it's fine. I'm wondering also if you have an email address to share with students in case they have extra questions with some specific questions maybe they can address directly to you.
Yes, thank you very much. It's very good point. So if you have any other question, you can address contact human.resources@esa.int.
Thank you very much. We'll put it also in the YouTube chat. And
Yes,
with this, I
very
ask
good.
everyone, maybe Christophe, you also have a Melissa.
Just one thing, this address is checked very, very regularly. So, and then my colleagues, they dispatch to whoever is responsible for the area in which the question is.
That's perfect. Thank you very much. Christophe, would you have a general email address or website students can visit for more information?
Yeah, it's very easy. It's melissa@esa.int.
Thank you very much.
And I advise you visit the melissafoundation.org, which is the Melissa Project website.
Excellent. We'll also write it in the chat for students to have it there. And Théodore, do you have also, is it the website or you prefer email if students have questions for you?
Yes, so I pasted my email if you can just add it to the chat.
Okay, perfect.
So it's theodore.besson at ESTE2E.com.
We will do that. Thank you very much. And
paste it.
Yeah, we will do that. And with this, we come to an end now that we hit the time just exactly on time. I would like to thank, first of all, the speakers for taking the time to share your experience with us and with all our viewers. We sincerely appreciate it. And we would like to thank, of course, as well, the audience for tuning in and watching this actually very stimulating discussion we had today. We hope that we cleared the doubts concerning the general landscape and your working opportunities in the life support systems field within the space sector in ESA and in Switzerland. And yes, we recommend everyone to follow up with the speakers if you have extra questions or through the websites. Also through the Swiss Space Center website, you can find more about our activities and also contacts there if you have more specific inquiries. So lastly, I would also like to ask everyone to fill in the survey. We have it in the video description. And don't miss next week's live sessions. We have engineering on focus with robotics and photonics, and science focusing on exoplanets next Monday and next Tuesday here on our YouTube channel. Thank you, everyone. Thank you also, Oliver.